Hello and welcome everybody in our axiometric drawing workshop. Let me really quickly introduce what we are going to do. Today we are going to look at how to set up and compose an axiometric drawing, a plan oblique with hand tools, and I'm really quickly just going to tell you what sort of tools you need to start with. So what you see on my drawing board is an architectural plan of the shelter. Or that this had been composed in Vectorworks, but you can just bring your hand-drawn 1 to 50 drawing. I recommend that if you only have access to an A4 printer, then you stay with the 1 to 50 scale, but otherwise if you had access to an A1 or A2 drawing board, you might actually venture out of that and you make your drawing at 1 to 20. Scale shouldn't really matter. Obviously, the larger scale you choose, the more detail you are going to have to include in that, but and obviously your printing, scanning and drawing surface capacities are going to stopping you from making any size drawings. So for now I'm going to demonstrate our workshop and suggest that you stick with the 1 to 50, but let's see what else do you need. So yes, we are starting from a plan. You have your architectural plan of the shelter. I also recommend that you actually have your elevations and your section with you as well, and for no other reason that you're going to need to know the heights and the measurements for your drawing. Other basic things you're going to need, which I believe you would have at home, hopefully accessible to you. It's quite handy to have masking tape. If you don't have masking tape, use magic tape, sellotape, worst comes to worst, that would also do. You're going to need pencils, drafting pencils. You can use normal pencils, but that means that, just like mine, you would have to sharpen the lead quite often. I'm actually going to make mine initially with that, and I'm going to potentially use these two to make my lines thicker. I'm also going to have a red pen or any different coloured pen just to actually make some marks for myself. Obviously rubber is very handy. I recommend that you actually either get a compass or a protractor. I didn't have a protractor, so I'm using a compass for my drawing to set up 45 degrees and to measure distances. You also want to have a scaled ruler to actually understand your heights at 1 to 50 to scale, and that you don't have to calculate all your measurements at 1 to 50. You should also have a straight edge. This is the one I managed to find, but it could be any ruler really. Just another one. I actually quite like these small ones. I've been testing this workshop out at home, and working to a 1 to 50 scale, I recommend that you have smaller tools. My retractable set square didn't work so well. I mean, I could maneuver around it, but I tried to fit everything into my camera. That was a bit of a struggle. So it comes into play every now and again, but not so much. Additionally, because of my retractable set square, I had also made myself a normal set square out of card. I had to make sure that this corner here is exactly 90 degrees. I also made myself, it's just made out of Kellogg's cornflakes, really, piece of card, but it's tiny, so it allows me to actually work really well with the two. And last but not least, what you're going to need, if you have it, but you might not have it, then we are going to work around that, some tracing papers. So let's just start. Right, so moving on from the introduction, I'm going to actually show you next how to set up your drawings. No, you're not mistaken, this is not a 1 to 50 drawing. After going through some motions, I had decided that I'm actually going to choose a larger drawing. This is a 1 to 20 half-scaled version of the shelter. So basically I cut the shelter in half. This is an architectural break line, just in case you don't know what this means. An architectural break line is representing that the shelter will continue behind this line. So the first starting point is that you get your plans out. and immediately, once your plan is out, oh, also don't forget to get yourself a piece of tracing paper handy. You're going to make your drawing on the trace. If you don't have any tracing paper, that's not the end of the world. It's just going to mean, so you can just compose your drawing right on this piece of paper, on your plan. It's just going to mean that potentially your lines are a little bit going to be more confusing because you are going to draw directly on this drawing. And in my case, as this is being a computer drawing, the lines are quite prominent. So somehow maybe try to tone your line weights down a tiny bit if you don't have access to tracing paper. So the next step is, what we are going to do is, if you are working on this page, then you are going to rotate your drawing at 45 degrees. So this means that we had rotated it at 45 degrees. If you're unsure how to do that, and to make it, so this is the 45 degree angle you are rotating it, but how do we get there, that we make that absolutely 100% accurate? Right, let me get on to that. These lines are already there in place, but I will show you how to do it step by step. Right, at this point, I'm temporarily going to fix my drawing down with a piece of masking paper because I just don't want it in the four corners. I don't want it to move as I'm moving my hand around. So just really quickly taping my corners down. And as we are drawing a plan oblique, that's part of the reason why we need to rotate your drawing at 45 degrees. If you've forgotten what kinds of other axonometric drawings you can make in various ways, then please look through the slideshow again. That will highlight this point or the importance of it. Okay, so we are done with this. So what we are trying to do is that we have the drawing like this and we are trying to rotate it in 45 degrees. What do we do? Next step, what I'd like you to do is, generally speaking, because the shutter is actually the end of the shutter is curved, it's very difficult to find a right angle corner. But is it? Actually, it isn't that difficult, because what we must remember, and this is a point we are going to keep coming back to, that although the end of the shutter is curved, in order for us to calculate and draw the curved end of the shutter, we always had to find the center point for this curve. And the way we had done it is that we encased it into a rectangle. So what I am actually going to do is to get my straight edge or set square in place, and I find this corner which is actually encasing the outer circle of the end of the shutter, and I'm going to slightly extend this line just like this. And what I'm going to do next is, I want you to look at this line here, so I'm choosing the other end of this rectangle here, and I am going to try to find a 45 degree angle here. Now if you're more lucky and you actually have a protractor, that's quite easy, so you can use the protractor, but I'm going to show you also another way. So with your protractor you can just mark out the 45 degree there, but let me show you what to do if you have access to a compass. So we know that if we're looking at the edge here and this extended line here, that this is 90 degrees. So what do we need to do? We need to halve it. And the way to halve it is that you just take any kind of radius with your compass and you mark it down on that end, you mark it down on the other side here, and then we are going to take the compass to that end there, move it over there, and here we go. Let's just double check, but I am pretty confident that we had found the 45 degree there. Could you see? It looks equal. It's also something you can eyeball, so if you don't have access to any kind of measuring device, what you could do, you can just draw a circle there and by eye actually try to divide it into half. But with a compass it's pretty easy. Cool, so next, what do? We want to rotate, make sure that we're rotating the drawing 45 degree. I'm going to extend this 45-degree angle here. I am going to remove my masking tape from my 4 corners, and I recommend that you also tape it down yourself. And this is the tricky part. We are just going to move the drawing in 45 degree. So what we want to see, that this line, this sort of ground line here, is actually, if you had a drawing board, it's parallel with your parallel motion. So you set up this horizontally as much as possible, and then you align your parallel motion to that. Now I don't have a drawing board, or I do have a drawing board, but I decided not to use it today because many of you don't have a drawing board. So with this simple technique, what you could see that we had just rotated the drawing from here to 45-degree angle there. And this is a very important starting point for our drawing. Now you can again use your masking tapes, and now you can just tape it down for yourself. This is going to be the basis of your drawing, so make sure that you secure it really well. I guess this is a good start for somebody who doesn't have tracing paper, but I also had done a quick demonstration with tracing paper. And what you could do, if you're working with your drawing plus a tracing paper, that you actually draw out your ground line here. You measure up 90 degrees on the top of that, you draw in your 45 degrees, and wherever you want, you secure this on the top of your plan and just set it up. And then you know that your plan is going to be definitely rotated in 45-degree angle. Okay? I am going to continue on my tracing paper, but you can do it either straight onto your plan or just do like me. Once you had secured your tracing paper and your plan is in place and you're ready with your pencil, your next step is that you start projecting up the vertical lines from all corners of your plan. Now you would say, what corners, Judith? I don't have any corners. The end of my shelter is completely curved. So what I'm going to do step by step, I'll show you how to deal with this corner here. But for ease, what I'm going to start with, this supporting wall between the back window and the end curve of the shelter. And then I work my way through the main outside walls of the shelter. Any details will come after, and the last thing I'm going to draw in is going to be the roof. So first I'm going to draw the main walls all around, potentially the columns, and then I am going to set up everything to start drawing the window panes in and the frames, and my last step will be to actually draw the roof curving around. Right, so this is how far I got. Just again, a little hint and tip. As you could see, I haven't secured my tracing paper down all the way, so I can flip it back and forth between my original drawing and my composed drawing. So this is, when I lift it up, you could see what I had done. As you could see, the structural opening and the ring beam here with the columns I had not included. Also, I haven't drawn in the details of the windows from the plan, only just the outline of the wall, the outside wall. And you could see how I started to project up the height of my walls, sort of perpendicular. So let me just really quickly show how that goes. You will remember my 90-degree angle. So basically what I had done is I have my corner there, and I line my corner and my ruler, just falls out of my picture slightly, to that line. And in an axometric drawing, you're going literally in up and in an x and y axis direction. And all I had done, that with my upright, I am drawing a parallel, and this is how I am getting the height for the walls. Okay? Right, so here we go. Next, I want to know that what's the height. This drawing is actually, I'm drawing at 1 to 20, but you're going to be working 1 to 50. So what you want to remember of and get off your orthogonal drawing page and your measurements page is actually the height of this parapet wall where the windows are sitting in. So I am there, and I just want to figure out the height there. So it says, sorry, I can't see it, 750. So what I want to do here, I get my scaled ruler out. Where's my scaled ruler? Here we go. And I want to find, you want to find the 1 to 50 part of your scaled ruler, and you want to measure up 750 onto your walls here. Obviously, in my case, I am using this drawing. This drawing is a 1 to 20, so I got to go and find the 1 to 20 markings on my ruler, and I need to go and get the 750 of this. Here we go. It's 600, 750, somewhere there. So I'm going to use that and mark that on in a second to find the edges of my walls. Just another quick hint and tip, what I recommend, because I am relentlessly going to mark up 750 onto these lines here, so that I don't have to look at these teeny markings on my scaled ruler. Sorry, by the way, this tiny one, which I find really useful to use, it has only got larger scale, so this is 1 to 200, but if you're taking a 0 off, then 750 is there, and you can use it perfectly for a 1 to 20 drawing too. So I had pre-marked my ruler there, and all I'm going to do, I'll show you, is that I get my pencil, I hold it there, and I know that as I go along, that this is going to be where my red marking is, that's 750, and that is going to show me where the window frame sits, where is the window ledge on this wall. So I'm going to do that all on these lines, hence it was worthwhile just to mark it up, otherwise it would have been really tedious having to look at it. I'm just looking at the red marking, red dot on there. Like that. So next I'm going to connect all these points up, and then I'm going to use my compass and I'm going to draw in where the window frame sits. What's important to remember that axonometric drawings or plane obliques are sitting in the parallel line drawing family. So how does this work? So let's just remember back when we had rotated our drawing in 45-degree angle. So what happens then, that you start having a three-dimensional grid, a three-dimensional system, where one of the edges here is what we call the x-axis. The other one you had drawn in, that's y-axis, and the last one, which is going to represent your vertical lines of your walls, is the z-axis. And these three axes here are allowing you to actually start composing your three-dimensional drawing. What's also really important, that everything drawn parallel to the x, y and z axes are going to be parallel. So that's one of the major differences between a perspective drawing and an axonometric drawing, because these lines would converge in a perspective drawing, whereas here in an axonometric drawing, it's very simply lines are being actually just plotted out parallel to each other. So this line here would become parallel to that. That means the top end of your wall is also going to be parallel. And what we had started to do, or what we are starting to do, is that we are setting up these principal axes here. And everything else which is not sitting on them, for example, the bay end of the shelter, or for example, one is going to be the windowsill here, sitting at the edge of the window frames, we are going to relate back to these major axes. Here, for example, with the windowsill, it's going to be the y-axis. So here what you are going to see is that I am going to try to find the top of the window ledge along the back wall. So what I am doing, I had measured up the height of the windowsill, and I am just drawing a pillar with the bottom edge of that here, and using my other pencil, and that is going to mark it out where it sits. Now this wall here in between the two windowsills, we know that that is a structural column, so we know that is much higher, taller than the edge of the windowsill. But regardless, first we want to find the edge of the windowsill, and then next we are going to engage with drawing in the concrete ring beam in a second. So there's one more there, and that's it. So we had drawn in all the lines defining the window ledge and parallel to one of our major axes, the x-axis. Now I am working my next set of lines to establish the windowsill, the window ledge on the back. And you could see here that here my marking for the top height of the window ledge is visible, but here I'm not 100% sure. So what do? Do I go back to my scaled ruler, or do I just actually use this sort of principle of drawing a line along the major parallel axes? And I had decided to show you how you can also find points through that principle. So we know that this angle here, everything running parallel with the back wall, the long wall, then it's going to run alongside the y-axis, and I know that this is the corner of my starting point of my window ledge. So just by drawing that in there, I could actually find it. Now I'm going to follow this through here. And this is it. So we know that this is actually, we had established here the window ledge. Right, so before we move on to actually figure out how to make three-dimensional the corner of the shelter, or the round part of the shelter, well, I suggest that let's draw the top edge of this structural column here. So again, just because I'm lazy, what I had done, I had marked on this measurement on my scaled ruler. So again, I went back to my drawing with all the measurements, and just bear in mind that I am looking at this measurement here, which takes you up to underneath the roof. But also, just one quick thing, you bear in mind that the top edge of the window, which we're going to need to know in a second, is not at the same height. So in order to find that in one of the following steps, you're going to have to take off 160, which is the ring beam, height of the ring beam, from this measurement here, which tells you the height underneath the roof. So I'm just looking at this, which I'm marking on here. So it's 2170. I guess the next question is, as we are moving into drawing up the window ledge at the corner of the shelter, or at the end of the shelter, but where the wall becomes curved, that how does a curve or a circle or anything like that behave in an axonometric drawing? Now, as we are talking about a plane oblique, so in a plane oblique, I'm just going to show you what happens. So, basic principles of a circle. This is a circle, just that please remember this is the radius and this is the diameter of the circle. Now, the way we are going to reproduce this circle is that we started off exactly the same way how we did with your plans. So we have a ground line, we projected up 90-degree angle. Again, we are doing a 45 degree plane oblique. There are some other ones, as we discussed in the presentation. There is the elevation oblique, but there is also 30-60 plane oblique drawings. But let's stick to this. So we know that if when we're looking at this, this equals to 180 degrees. Now we're taking off 45. We had also taken off 45. So that's together 90. So when you're taking off 90 degrees out of 180, which is this whole angle here, then we know that this stays as a right angle. Now how we are going to draw out our circle. So I'm sticking with, I'm using my compass, and this was the radius of this circle here was about 30 millimeters. And what's worth remembering that a really easy way to compose irregular shapes in an axonometric drawing, that you're overdrawing it. Now, here, what I'm going to go on is the basic principle that how we can actually fit a circle into the square. And in order to do that, again, drawing along the y principal angle and the x, this was our z principal angle, but we're not going to need that at the second. So let's just stick to these two. I had measured up so again, we had found our three principal angles. This is the x, this is the y, and this is the z principal angle, but I just left it ever so faint because I want us to focus on these two. So we are talking about a 3 centimeter radius circle. As you could see, that's 3 centimeters. And what I'd like us to remember is what happens if you are trying to encase a circle into a square. That means, as you're going to see in a second, is that the circle will be touching perpendicularly points of the square. So it is quite important that when we come back to our shelter, after understanding that how actually a circle does not change in a plane oblique at all, what we want to do is we want to find the center point of our circle. We want to understand the radius for these various curved lines. And once we had done that, what we could start doing is actually creating and enclosing it into a square. So I already have mine drawn out here, but I am just going to highlight it for you guys. We know that this is the center point of our circle or arc. Just to come back, please draw it on with a faint line. Yes. And the next important point we had already drawn in here, or I had already drawn here, is the major axes around at the edges of the square, and I had projected up the height of my arc for the curved part of the shelter. The one last thing I had forgotten to do, or I haven't done yet, is that I am going to do exactly the same. That I am going to draw in my z-axis from the center point onwards, and I'm going to get my scaled ruler out, and I am going to draw on the height, the edge of the window ledge, like so. This means that when we are drawing out the window ledge, we know that the center point for that we had projected up 700 and what was it, 20 or 750 as the height of the window ledge. We just make sure that the radius for our window ledge is correct. Do that. However, I just noticed one inaccuracy, and namely that actually, and please remember that for that, guys, that I am trying to match my radius to that point. That is wrong, because we know that actually the end of the arc is here, and I just noticed that I haven't projected up that line there. So don't do the same mistake. Go up, measure up, find your 750. There we go. Here I am just going to go back on here and erase it, and I make sure that my arc starts there, and it is right there, and it is right there. That's better. Okay. Now it's good. Okay. So here we go. There's the inner sort of circle of our arc. I'm going to attempt the outer one of the window ledge that is there, and in order to comply with that, I'm gonna have to again project up the line on the other side from here, mark on my 750, where is my 1 to 200, there we go, from this point like so, and I am going to use my compass, make sure that I am applying the right radius. Note that the outer edge, the furthermost out arc, is actually the window ledge. We are not quite drawing that yet. Well, let's hope I am going to be accurate. Okay, go there. And there you go. Okay. So now we have actually drawn very excitingly, the window ledge for our shelter. Now what I'm going to do next is draw in the window frames, or mark up where the window frames are going. I could see it in the plan drawing that actually they are sitting inset at the center of the structural opening, the wall. So I'm going to have to halve this distance here and draw an arc in this dimension there. And then I'm going to know where all the window frames are placed, and then I can actually just start drawing them in. So before we draw the window frames in, I just decided to show you how to draw the window ledge, because we haven't talked about it. So just that you all understand what I am going to go on about, I really quickly going to draw you a sectional view of the window ledge. So this is the frame. Do we remember all this? This is the glass, this is the weathering drip. Fine. So you have everything there. And what's going to really cause the issue is none of these lines here. I mean, let's just forget the window drip for a second, or the weathering drip. But what I want us to focus is this angle here, because that is going to cause us the problem on how to actually draw the window ledge. So let's name them. So that is going to be A, B, C, and D. And what we are going to do is, initially, we are going to box this corner in and pretend that the window ledge is a square. And once we had done that, then as long as we know this distance here, then we can take it away from the window ledge there. So this angle here will not comply with any of the major axes in the drawing, hence we're going to have to calculate it like that. So let me just show you how to get on with that. So here we go, we are on the top of the wall. I also just read off that our window ledge is about 70 millimeters. So I'm measuring this on here, and I am projecting up this bit here as well. And I am going to extend that up, initially pretend that that is just a box. Yeah? So what we are going to do next is going to draw this line parallel to that. Okay, that marking there didn't quite work. So we know that that rectangle is here. Okay? Now, from there, we can start literally projecting it in here. Yeah? So just to use this thicker pen, we know that the slope actually starts where the structural opening is, here in this point, which is point B. Yes, I had drawn that in. This point here is point E in this corner. This C point is here, and this D point is just here. So once I had drawn out the profile of the window ledge, then it's a very simple exercise of actually complying with all the principal y-axes and drawing them in. So I am going to actually use my big set square to do that, and I'm going to try to make it as accurate as possible, and I'll show you the result. So I know it's not very easy to see, but this is what we got so far, and we had drawn in all the parts of the windowsill. I'm going to repeat it on this side again, and then I will use a thicker, softer pencil to actually show it to all of you.